Namaste, welcome back to Stithapragna channel and you are watching AWS Cloud Projects for Beginner to Expert. How are you all doing and are you guys enjoying this series so far? Okay. Wow, he's right here. I didn't expect that. Okay. So are you guys enjoying this playlist or series, whatever you want to call it? Let me know in the comments. And yeah, I think if we finish this one and one more, then we are done with the networking role projects. Then we will go into machine learning. I'm excited for that one, and that is going to be the last season, which we will, I think we will have about 15 projects in the machine learning. I'm excited about it because on the side I'm also preparing and watching statistics videos because I want to learn about more machine learning, uh, etc. So I am also watching them, so I'd want to see how or what are the services or projects, real-time projects that AWS has. So I'm excited about that one. But anyways, so today's project number is 78. It is about resolve VPC routing conflicts. Hey, we are in a tight spot. Our space network engineer can't access our Spacedock Traffic Management system. Did he dress just like us? We are spread across three VPCs with an application load balancer, web servers, and databases. Could this be a routing conflict? Don't worry, we can break this down. Okay, what's the first step? First, we will verify connectivity between your VPCs to ensure that they are communicating correctly. And if they are not, we will adjust the settings. Next, we will investigate why your web servers aren't processing requests. Sounds complex. What about the application load balancers and database? Good question. We will check the load balancer configuration to ensure it's routing traffic correctly. We will also ensure that the databases are operational and accessible. This seems like a massive task. Can we really manage it? Absolutely. It's a complex issue, but we will work together to solve the routing conflict. We are not alone. We will get this sorted. Can you help us troubleshoot? Of course, I will help you. Great. I can't wait to see this issue resolved. Okay, what are we going to do? We will update VPC peering routing tables between servers. Then we'll update the application load balancer configuration and finally routing table between server and the database. Okay, let's go ahead and look at the video concepts. Here we have video concepts for ELB, VPC peering and RDS, and watch them. I highly recommend them. There will be a link right here. Click on it. It will take you to AWS tutorials for beginners. Then search with these titles in that playlist and watch the videos and then come back and resume the project. So let's go through our steps. This solution covers various troubleshooting strategies to address the issue of three-tier application that generates a 503 error when accessed through an application load balancers on the AWS. The solution investigates potential routing conflicts arising from VPC peering aimed at restoring complete functionality to the application. Obviously, whenever you are peering between two VPCs, you will first check if they are actually talking to each other, if you are able to ping the other VPC services, etc. or not. Once that is fixed, then you will come and check if application load balancer is actually sending appropriate traffic to these machines or not. So I think they will explain. Let's go through it. A load balancer serves as the single point of contact for clients because that's where they enter, and this will be in the public. Most of the time this will be in the public subnet and these machines will be in the private subnet. The load balancer distributes incoming traffic across multiple targets such as EC2 instance in multiple availability zones. The load balancer, application servers, and databases are all situated in distinct VPCs. You can see, right? VPC, VPC, VPC. Connectivity between these VPCs is achieved through VPC peering. The application load balancer uses a round robin strategy to distribute traffic among the servers. Right? Round robin, one, 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 again one, 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 something like that. A VPC peering connection is a networking connection between two VPCs that can be used to route traffic between the VPCs using IPv4 addresses or IPv6. Instances in either VPC can communicate with each other as if they are within the same network. It's like extension to the existing VPC, connecting both together. Like when you connect your monitor to your laptop, right? The application servers and database servers are positioned within private subnets, and a private subnet is a subnet not directly accessible from the internet, ensuring enhanced security for sensitive. The configuration of the AWS application load balancer is checked to ensure that it is correct. The configuration includes settings related to security groups, target groups, listeners, and routing roles. The health of the individual tiers in the application are checked. A problem with one of the tiers might be causing the entire application to return a 503. We never know. Any potential conflicts in the routing tables due to VPC peering, right? You need to make sure that the CIDR blocks for each VPC don't overlap. Are checked. The peering connection configuration is validated and setup of the route tables is viewed. Network or routing conflicts can disrupt the application's access to database. Issues can indicate a potential routing conflict within a VPC peering setup. So they are checking, as you can see here, right? After issues have been resolved, a thorough test is conducted to ensure that the three-tier application is fully functional and no longer returns errors. Interesting. I like debugging a lot. So this is up my tier. Practice lab goals. Let's review the connectivity between ALB and the servers. Then update the ALB target groups, which is available on this one, to include the application servers. Then update the routing tables to route traffic between ALB VPC and app VPC connected by VPC peering. Then let's use the ALB DNS name to validate access to the application servers. As part of DIY, we are going to update the route table to the route traffic between the app VPC and database VPC. Then we'll use the ALB, similar one, but between these two. So let's go ahead and do the practice session. I'm excited about this. Actually, I can just add this to my resume once I finish doing it. Okay, as usual, I'm not going to talk about the concepts. You read it, pause the video, read it. I only read it if it is something that I am not familiar with. So let's go to VPC. Okay, and we are going to check the application load balancer VPC. Let's review. It is available, and we can even check the its CIDR range. Okay, let's go to VPC ALB CIDR block, which is 192.168. Okay, let's click next, and let's click on resource map now, so that it is going to show you how the flow is happening here. The resource map shows interconnections between resources within a VPC. The map also shows the flow of traffic between subnets, internet gateway, NAT gateways, and gateway endpoints. Okay, this is the first time I'm checking it now, but this is interesting. As you can see, VPC, then subnets, then route tables, then maybe security groups. Okay, now let's go repeat the same process and let's copy the CIDRs for other VPCs. Now let's go to EC2 and let me scroll down so that you can read the complete one. Instances, app instance 1, review, copy the IPv4, private IPv4, okay. EC2, good. Then we are going to clear that and go to EC2, copy it. So we are going to just repeat it for all three. All three or two. I think just two, that's fine. Even if we have third one. Then we are going to connect to third one, or probe instance. The probe instance in the EC2 instance hosted in the same VPC as the application ALB. This instance is specifically configured to troubleshoot connectivity issues within the environment. Awesome. Then let's go to session manager connect, which we already know. And we are going to run curl iv that this command tests the reachability of the application on port 80. The curl command with the iv option is used to send a head request to the specified URL and display output including response headers during the process. Allow for the test to be completed. A response of 200 indicates that the application is reachable and functioning properly. Okay, let's go ahead and copy it. So this is testing that the instance, this application instance 1 is reachable on the URL, that URL and the port 80, that to port 80. Okay, interesting. And we are going to repeat the same for the other one as well, because remember this probe is, think of the probe as application load balancer. So if you can do the curl and reach both the IP addresses, which means application load balancer is able to talk to both the instances. That's what we are testing right here. The first one it succeeded, but the second one looks like it is not succeeding, so it is unable to connect to instance 2. Okay, it failed. So what are we going to do? Then we will immediately go to the application load balancer and then let's click on the DNS name. Okay, now let's go to the probe again. Okay, let's run the same command, which is the curl, but this time we are trying to check the application load balancer's DNS name. This command again performs reachability test for the application load balancer on port 80. If you receive a 503 service temporarily unable response, the server side of the application is currently unable to handle the request, which is what they showed it here. ALB functions at the application layer, the 7th layer of the OSI model. After the load balancer receives a request, it evaluates the listener rules in the priority order to determine which rule to apply and then selects a target. Okay, that is not working, so we are going to go for the target groups and click on the one that is created for us. Target group, open that lab one and target 0. Actually, it is, they didn't even create anything. Okay, then let's register target. Okay, choose a network. Okay, other private IP address, then choose all. Okay, you register your targets with a target group. When you create a target group, you specify its target type, which determines how you register its targets. For example, you can register instance IDs, IP addresses, or Lambda functions as targets. And specify IPs, we are going to paste the IP of instance 1, app instance 1, and then click IPv4 address, and then we'll paste instance 2 as well. So, okay, if we didn't copy paste both the, I mean, like, how is it reaching the instance 1 and not 2? Port is 30, then include as pending below. Include as pending below. What does that mean? Okay, pending. Okay, then review it, register pending targets, then refresh it, health status initial. After you specify a target group in a rule for a listener, the load balancer continually monitors the health of all targets registered with the target group that are in an availability zone enabled. Load balancer routes request to, and as you can see clearly, the second one is unhealthy, first one is healthy, which is why we were able to ping it. Nice. Now let's go ahead and see why we are able to only reach to one and not the other one. You can use a VPC peering connection to route traffic between VPCs using private IPv4, IPv6. So we are going to VPC peering connections, then ALB to app, and let's review. Okay, let's review it, and then let's go to route tables, review the route tables. All right. Basically, route table will have its route table ID and etc. So ALB public one, app private one, and let's go and click the app to DB, and then route tables review it. Okay. Now let's go to route tables, which is right here. Route table, if you remember the projects we did, route table, that is the entry point, right? Whatever is coming from, whether it is internal or external, goes to route table. Then route table sees based on the CIDR where it needs to send it to. So route tables, the ALB public one, what does it have? It has an internet gateway which will make it talk to the public internet to and fro. Then it has a local so that it will talk to all locals destination. Anything that comes hits this one, it's local VPC, it will send it to. And anything that comes from this CIDR block, it will send it to this one. Target, whatever the target is, we will see in a minute. But what are we doing right now? Route tables, ALB public one. Let's review it. And then public two, if you look at here, local is there, IGW is there, but the public one had what? Do you remember 10.0.0.0.16/16? But here it doesn't have it. Note that a route is missing for the subnet, that one. The route 2 follows default route to the internet gateway. Okay, that is passing to the internet gateway, which is missing. Okay, so route table ALB public 2, edit the route so that you can add 10.0.0.0/16. Okay, then add, click on add, enter that. This is what we are picking. What are we picking? We are picking target is okay. That's what is missing. What is the target? Target is this particular VPC peering connection that you created, which is ALB to app. Okay, so because this IP address, I guess it is the app. I didn't copy it. When we do it, we will get more clarification on that. So it doesn't know how to talk to it because you are not routing it. Save changes. Now let's select, and since this is the time, let's check for app private one, review it, and looks like if you see, it's talking to the others. It has an ad because it's in private subnet, and then it has these two, which is good. Note that the destination subnets and are routed to VPC peering connections. All traffic that does not match specific route in this table is directed to the NAT. And private V2, if you see, this is again missing some stuff. Note a route is missing for subnet 192, this one. You need to add that one. Okay. So that is for app P2. Okay. Once you edit it, once you add it, you are going to tell it which one is this. I think this CIDR belongs to the app. Is it app? I don't know. Which one? Okay, we are in the app route, so it belongs to the ALB. So we have to tell it to send that traffic to that one. Okay, so when you are in the app private 2 instance, okay, whenever you are sending traffic, trying to send it to this one, that particular VPC don't know that one because its seeder block is 10.0. So it will come to the route table. Right now, if you don't point it where you need to send the traffic to, it will be like, I'm lost, I don't know. But now we are telling anything you see on that instance, send it to this particular one. Okay, cool. Okay, so far good, I guess. And then we are going to go to target groups. Now it should mark it as healthy. Okay, I kill that. And now, what is this? Oh, the ALB DNS name we copied. If we paste it in the browser, it will show this. Okay. Error connecting database. We are working to resolve the issue. Who is working? I am working to resolve the issue. Review the instance ID and the availability zone. And if you refresh it, it will go into talk to the other one. So you are unable to connect to either of those availability zones. Okay. What happened? Okay. Click add spaceship, and it is opening this one. I think this is the applications one, I am assuming. Uh, Fixed, I didn't fix it. On the top now, click add space, review the form. After the database connectivity is fixed, you can successfully submit the form. Okay, now it is not. I think that is part of the DIY. And let's go to RDS. Click on that one. Review it for the DIY. Okay, interesting. Okay, I think, what do you guys think? It is interesting, but I think we cannot just immediate. Oh no, I don't know why I'm here. We cannot expect us to learn all the debugging things that are there for networking. It takes some time, but I think I would have done it. Seriously, I would have done it. Okay, let's go to VPC because we have done enough projects based on the things that they showed us. So let's go to VPCs. Okay, ALB cedar block is this one. It starts with 192. Okay, let me paste it. And then application servers is 10, and the other one will be, I guess, 172. Oh, it is right here. I don't know why I'm opening up it. Okay, this one is the database. So let's go back, click on this one, click on resource map. It will show you, as you can see, it's going from VPC to subnets, subnets to route tables, then to network connections, which is the load balancer. Interesting. Okay, and this one, subnets. Oh, okay, you have a public and private. That's interesting. And you have the route tables and then the network connections for all of them. Okay, nice. Let's go to EC2s. I don't know where it is. Okay, this is from the old ones. Okay, okay, we are in EC2s. Instances running. Okay, now let's go get the app instance one. Networking. Copy the IPv4. And let me do the same thing for the other one. Okay, good. Now let's try to test it by the probe. Remember, probe instance is nothing but the, think of it as like the application load balancer. But since we cannot log into application load balancer's machine, we created this to replicate that one. Okay, once we are here, let's go ahead and execute this particular command they gave us. Let me do it on my, what we are going to use, we are going to use the curl connected, you can see. I think it takes some time. They said 10 to 20 seconds or something, but at least it is saying that it is connected to that on port 80. Should I wait? I think we are good. Okay, now let me paste the other one. For this is the app instance too. As you can see, it is trying, but it cannot connect to it. So we know the problem is there. So ALB is unable to connect to the other one. Now let's go back to this one. So what am I trying to do? I am trying to locations, not here. Now, where is the load balancers? Are they on not on EC2? Yeah, oh here, never mind. And we already have it. Click on it. I want the load balancer DNS name. So let's go ahead and put it. And let's try to do the same thing to check if actually we are able to listen to application load balancer on port 80. I think we should be able to. Yeah, it connected, which looks nice, no problem whatsoever. Now let's go ahead and target groups. Let's see if you click on that one, and if you see there are no target groups, so let's create target groups. Oh, I think this changed. I think, is it IP addresses? Yeah, target group name. What is the name I put? I will just put an HTTP IPv4. Is this what we created? No, we don't want to create this one. Okay, leave it. There is already target group. What we want to do is register targets. That's what we want to do. I was like, no, that's not what I want to do. And here we are going to give the IP addresses of instance 1, which is this one, and then app instance 2, which is this one. Okay, 80 include as pending below. Okay, what, that is not other private IP addresses. That's what we are supposed to put, not this one. Okay, that's why it failed. Okay, let's select that one. Now do that, pending, register. Okay, I think it might take some time. Let me see. How do I scroll down? Okay, here we go. Initial, normal, normal. As you can see, as expected, instance 1 is healthy. That is timed out. It is not healthy. We proved it from logging into session manager and trying to correct to it, and as well as this one. Okay, so that we confirmed from both of them, which is good. I'm happy. Now let's go to VPC and let's check whether our routing tables are properly configured or not. So peering connections, we have both the peering connections. Let's select ALB2 app. Okay, and that's cedar blocks, we already have them. Then if you click on route tables, you can see it has two route tables. Same thing, if you go here, it has one route table. Now let's go ahead to the route tables, which are right here. Okay, and let's go to the ALB's route tables first. Public one, because it's in public subnet, they just named it that. And if you click on routes here, you can see we are clearly what is this one? This is the apps, right? So from public one, we are able to route traffic to the app 1 VPC. It's not app 1, app VPC. But from public 2, we are not able to route. Okay, this is just the VPC of ALB. But how are we sending or connecting to that other one? We are not. So let's go ahead and add that and let's enable that. So this is the seeder block of the app VPC, and we are telling send it to the peering connection, which is this one, ALB to the app, save changes. Now from availability zone 2 or that ALB another availability zone, it should be able to successfully connect with that. Now let's go ahead and check for other route tables as well, which is the private one app, by the way. Oh, sorry, I'm selecting to go to routes, and if you see, it is this is the seeder of app, so no problem. This is the seeder of what is it? Database VPC, and this is a ALB VPC, which is all good. But if we go do the same thing for private 2, it's not talking to any other VPC. So let's go ahead and fix that up. For this one, we can just add the ALBs. But anyways, as part of DIY, we have to connect to the this we are connecting to this one. Okay, let's go ahead and do that as well. We need to connect it to the DB VPC as well. So let's paste that here and let's go. And the connection we are giving is for the DB's VPC peering. That is the one. Okay. So we have both of them right here. I think once this is fixed, if we go back to this won't take me back. Target group, refresh it. Now see, both are fixed, both are healthy. Now let me go back and try to click on this one. I mean, I wouldn't be surprised if the database connectivity happens. You might be like, why? Because I added the entry there, right? I don't know why this is not opening up. Or should I give HTTPS? Or maybe I need to give the port. Okay, hold on a minute. What is the port? Oh, come on, seriously? Maybe 80? That's it. Okay, they are not doing that. Okay, do I need to give any of this? I mean, this should work for us. I don't see why it's not. So let me go here. Application load balancer. Okay, here we go. And okay, why not? It worked. Okay, now you can see error. Okay, it is still not. If I refresh it, it should connect to. This is for the available zone 1B, 1A. It should be able to connect. If I refresh this, round robin, right? If it's sent to this one, the next one has to go to the other one. Next request. So let's see whenever it does. And in the meantime, we can go to the RDS. They just asked us to review this, right? Yeah, we can review that for the later one. I don't know how long this is going to take, but that's about it. I enjoyed it. Now let's go ahead and do the update the routing table to route traffic between app VPC and which I already did. Use the DNS name to validate access to the application servers and the database. Yeah, it's still not doing it. Check host, which is what they are asking us to do. Or maybe the database, it is not. Host name. They asked us to check both the ones, right? Okay, let me copy the application. This is the application. Check status. Something is in a, or it's talking about database. Oh, we have to use the database status page. Okay. The database checks it? What? Not sure. Okay, that's fine. Let's go to the routing tables. We checked for private, we checked for, but we didn't check for that database. So let's go and check for that one. Database is in private, so we only care about private 1 and 2 routes. And this is only talking to its own. It has to talk to the other two, not to other two, but only the app server. So let's go put that, and it's going to be peering for app. Save it. Now let's do the same thing for the other private one. DB private. Okay, that is private one. Okay, let's do private two. Okay, save changes. I think this should fix it. So let's click on this one. But I don't know why it is taking this long. It is not supposed to take this long. I don't need this one. So let's click enter. And what do they want? ALB target group name. I think we know where it is. Oh, this is, yeah, VPC lattice. That is something new. Okay, here is a list of all near light speed ships. So you can see it is connecting to the database successfully. Ship name. Origin is Earth. Pandora. Submit it. Thank you for registering. You are authorized to refill the supplies. We added the ship. I think it's okay. I think this is all fine. Now let's go to the EC2. Let's go to the target groups. And they want the target group name, right? I think that's what they asked for. Target group name. I think this should work. I am confident. Yes, I am confident because pretty much everything is working. Okay. I think that's about this project, everyone. I hope you enjoyed it. I enjoyed it because debugging is something that I really like a lot, whether it is application connectivity. Done your space network engineering should have normal access to the application database. Okay, or whether it is application code issues as well, data related issues. Okay, so let's go ahead and you know what comes next. It's the quiz time. Let's see who will win the quiz. Okay, come on. I don't know why it happens here. And we are left with one more project in the networking role. And we are going to, yeah, one more and I will get this badge. I'm excited about it. Cancel. Okay, let's go and zap those drones. Let's see who will win. I'm confident that I will win this. Are you guys confident as well? Let's see. Come on, don't. I, it's stuck. Okay, it's not stuck. Which type of VPC endpoint can be used with private link to access other services from within a VPC? It's interface. Gateway doesn't use private link. Interface endpoint uses it. One love. And again, pause the screen. Don't check for my answer and then answer. That's called cheating. Okay, I hope you all don't cheat. 1-0. What does a routing table entry for a peered VPC contain on AWS? Cedar block of the peered VPC? Yeah, we just did it. Duh. Too low. I told you I am going to dominate this one. I mean, we are almost at the end of the network, so obviously, which of the following does an APC VPC endpoint create in a subnet? Mm, I think static route is for what? I think it's the transit gateway, I'm assuming. Is it ENI? Mm, I'm assuming. I don't know. Let's check. Yes, this creates an elastic network interface in the subnet that serves as an entry point. Yes. All right. 3-0. How are you all doing? I am at 3-0. Are you at 3-0 as well? I hope. So, what is the private zone used for in Route 53? I know this. We did a project, remember? Route traffic to S3, nope. Route traffic to specified, nope. Route traffic to the internet, definitely not. Route traffic in VPCs, private, I mean, it doesn't have to be S3, but you can do it for S3 as well. But is it within VPC? I think it is this one. Yeah. How to route traffic in your VPC? Yeah, I'm rocking. 4-0. 4-0. How are you all doing? 4-0. Which log captures information about IP traffic going? This, come on, seriously? 5-0. Okay, let's check one more and see if the questions, yeah, if we are finished with the questions. VPC peering on AWS can be used to allow routing between VPCs that belong. Yes, we can. 6-0. There is no stopping me. No one can stop me. Oops. 6-0. How are you all doing? Are you close to me? Oh, did I shoot that one? That's okay. You can take a break. You all can take a break. Okay, I have all the container cognito gateway. The marketing department chose to build its API with Docker containers. The department wants a solution to, yeah, I think we know how to do this. Gateway, you can have it here because this is the entry point to all the applications. And then we have the Cognito going there, but where is it? I think it is this. And then we have the containers going on the here, and oh, we only have one. Huh, that won't work. Even this, yeah, yeah, we don't have the other one. So yeah, I think that's weird. Okay, let's exit. I cannot finish it. So let's go ahead and do one more quiz and see if it is going to ask us about VPC peering or not. Which statement best describes the function of a traffic mirroring? Okay, it is asking from our previous project. It determines which traffic is copied from a traffic. No, not the session. This is filter. It establishes relation between traffic source and traffic mirror target. Yeah, that's about it. 7-0. I think that's about it, everyone. Do comment, and in the comment put my score, which is 7-0, and your score. I need to know who won. So, okay, I hope you enjoyed this project. I did really enjoy it because this is one of those projects where we do the debugging, even though they told us what to do. But still, I mean, we failed to do some projects that even though they showed us step by step. All right, thank you very much for spending your time here. If you haven't subscribed, go ahead and subscribe, like, comment, and do all that amazing stuff. Have a great day. See you in the next video. Peace out.